Okay, hi, I'm going to do section 4.4 on fractional exponents and radicals, but I'm going to warn you, I'm really tired. I've been farting around with this computer for 2 hours trying to get this to work, so I'm just going to run right through this, and I'm going to leave any errors, unless they're really egregious. Okay, the plan is to complete these tables using a calculator, and I want you to write down the buttons you need to press on your calculator, because that's really important that you understand how to use your calculator. So this table has x is 1, and we're doing x to the power of 1/2. So the first one is 1 to the 1/2, and that is 1. Now on my calculator, that pen's probably not fat enough, is it? On my calculator, I would have to press 1 to the power of, open brackets, 1 divided by 2, and that will give me 1. If I did 1 to the power of 1 divided by 2, that will actually give me 0.5, because what the calculator is going to do is it's going to do 1 to the power of 1, which is 1, then it's going to divide that by 2. All right, and we need it to be doing to the power of the 1/2. Okay. I'm just going to fix my pens. Okay, so 4 to the 1/2 is 2, and then you need to do 9 to the 1/2 and 16 to the 1/2. Okay, I'm going to pause the video, and you're going to go ahead and complete that, and then come back and see if you're getting the same answers as me. Okay? Okay, there are the answers. Take a look at them. Hopefully you got the same as I did. If not, go and figure out how to make your calculator work so you do get those answers. Okay, next page, or bottom of the page. What do you notice about these numbers? Well, hopefully you notice that the second column is the square root of the first. And in this column, it's the cube root on the second table. Okay, the second column is the cube root of the first. So what do you think the exponent of 1/2 means? Well, it means square root. So we can say that a to the 1/2 is the same as the square root of a. And the exponent 1/3 is cube root, so a to the 1/3 is the cube root of a. And 1/4 and 1/5, the same thing, a to the 1/4 is the fourth root of a, and a to the 1/5 is the fifth root of a. So what does a to the 1, or sorry, oh my goodness. What does a to the 1 over not on a to the 1 over n mean? It means the nth root. So a to the 1 over n is the nth root of a. Okay? Let's go and look at the rules now. So in grade 9, you learned the multiplication rule of exponents, where a to the power of m times a to the power of n is a to the m plus n. And we only did that with integer bases and whole number exponents. Today we're going to extend that rule to apply to fractional exponents. So we're going to write this up with 5, whoops, it's not a 5, 5 to the 1/2 times 5 to the 1/2. According to this rule we have here, that equals 5 to the 1/2 plus 1/2, which equals 5 to the 2 over 2, which is 5 to the 1 over 1, which is just 5. And we know that the square root of 5 times the square root of 5 is the square root of 25, which equals 5. So that means that 5 to the 1/2 is the same as the square root of 5. I'm going to do the same thing with the cube root. 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. That equals 8 to the 1/3 plus 1/3 plus 1/3, which equals 8 to the 3 over 3, which is just 8. And if I write this instead as the cube root, and we know that the cube root of 8 times the cube root of 8 times the cube root of 8, which is 2 times 2 times 2, that also equals 8. So 8 to the 1/3 must equal the cube root of 8. Okay, so we're going to make this a rule, and we're going to say that x to the 1 over n equals the nth root of x. So we've shown that two ways. We've shown that in examples on the first page. We're looking at tables, and we've shown it with looking at algebra here. Okay, let's do something with this. Okay, so evaluate each power without using a calculator. So 1,000 to the power to the 1/3 is the same as the cube root of 1,000, which we should recognize is 10. And 0.25 to the 1/2 is the same as the square root of 0.25. Now, that 25 is on our table, so we should be looking for 5 as the square root of this. So it is actually 0.5. Negative 8 to the 1/3 is the same as the cube root of negative 8. And we should know or get from our table that the cube root of positive 8 is 2, so the cube root of negative 8 is negative 2. Sorry, negative 2. And 16 over 81 to the 1/4. Also using rules from last year, we know that this is 16 to the 1/4 over 81 to the 1/4. So that equals the 4th root of 16. That's the 4th root. Oh, the 4th root of 16 divided by the 4th root of 81. And from our handy dandy chart that I told you was going to come in really handy, the 4th root of 16 is 2, and the 4th root of 81 is 3, so that's our answer. Now, please note, this is an exact answer. Do not convert to decimal. Okay, the decimal answer for that one is wrong. We need to leave it as a fraction. Okay, your turn. Pause the video. Go and figure out the answers to the next two questions. Okay, so this is the square root of 0.49. Which is 0.7. And this is the square root of negative 64. Sorry, the cube root. It's not very clear on my page. That's the cube root, which is we know that the cube root of 64 is 4, so this is going to be negative 4. All right, next page. Okay, Recall another exponent rule. X to the power of A to the B is the same as x to the A times B. This means that x to the AB equals x to the A to the B. And because x to the AB is the same as x to the BA, because it doesn't matter what order we multiply things in, x to the AB also equals x to the B to the A. So 8 to the 2 over 3, we can write that as 8 to the 2 times 1/3, which we can then write as 8 squared to the power of 1 over 3. I'm sorry this is not coming out very clearly. The tablet seems to be super sensitive today, and because I'm using it on a different computer. And it's already past my bedtime, so I'm not going to fix it. So this is the cube root of 8 squared. And 8 squared is 64, so this is the cube root of 64, which is 4. Now if we go back and we multiply this out, we do this a different way. We write this instead, 8 to the 2/3 equals 8 to the 1/3 times 2. Then this becomes 8 to the 1/3 squared, which is the cube root of 8 squared. And the cube root of 8 is 2 squared. Oh, we get 4 again. Yay! So what we see from this is we can say that 8 to the 2 over 3 can be written as the cube root of 8 squared with the square under the radical sign, and it also equals 8 to the 2/3, it also equals the cube root of 8 all squared, like that. Okay? So the rule here, there are actually 2 rules, but I'm just going to give you one. And that goes like this. X to the m over n, I'm going to combine it into one rule, equals the nth root of x to the m. And it also it also equals the nth root of x in brackets to the m. Okay? Now usually the second one is the one you'll use because it's, in our example with 8s, it didn't make such a difference because the numbers were pretty small, but if the numbers are big, it's usually easier to take the root of it, the square root of the cube root of the 4th root, and then raise that to the 8th power or something like that. You'll see an example of that. Okay, so let's practice writing these in 2 different ways. So 26 to the 2 over 5. Now the thing you remember is that this number stays as exponent. And the denominator becomes the index. So 26 to the 2 over 5 becomes the 5th root of 26 squared, or the 5th root of 26 all in brackets and square the whole thing. Okay? But the one that's in the numerator over here always stays as the up top number is how I think of it. That's the up top, that's the exponent. Okay? Okay, and for this one, for the square root of 6 to the 5, remember there's actually a 2 here. We don't always write it. In fact, we don't write it, but it is there. So this becomes 6 to the 5 over 2. And the fourth root of 19 cubed, well, there's our 19. The 3 is the exponent, it stays on top, and the 4 becomes the denominator. And again, that looks like a 9 because of this pen. There. Okay, your turn. Pause the video. Go ahead and do this work. Okay, hopefully you got that this is the cube root of 40 squared, and it's also the cube root of 40 all squared. A couple more on the next page. The square root of 3 to the 5 is 3 to the 5 over 2, and the cube root of 25 squared is 25 to the 2 over 3. All right, we're halfway through. We're going to, okay, evaluating powers. So in those examples, we were just asked to rewrite them in exponent form or radical form. This time, we're actually going to evaluate with a number, and this time we have rational exponents, or sorry, on rational basis. So this time we not just dealing with integers, but we can have decimals and as our base. Okay, so 0.01 to the 3 over 2. That can be written as the square root 0.01 cubed, or the square root of 0.01 and then cube the whole thing. And the second way is easier because the square root of 0.01 is 0.1, and then to cube that, we get 0.001. All right? Now, this negative 27 to the 4 over 3 is the cube root of negative 27 to the 4. Now we need brackets around that because the whole negative 7 is to the 4, not just the 27. Or this is the cube root of negative 27 to the 4. Now I didn't put brackets in around the 27, negative 27 this time because it's under the radical sign, and that implies brackets on its own. So the cube root of negative 27 is negative 3, and that's to the power of 4, and I am going to put that in brackets because the whole thing is to the power of 4. 3 to the 4 is 81, and because it's an even exponent, it will be positive 81. Okay. Oh, and just check this out. If I did this one, this works out to, we need to find the cube root of 531,441. So it's a ridiculously huge number. I mean, you can do that on your calculator, but if it was a much bigger number, you wouldn't be able to because your calculator doesn't do numbers that high. Okay, so that's why we usually take the root first and then do the exponent. Okay, this one, 81 to the 0.75, what we need to do is write this as a fraction. So that's 81 to the 3 over 4. And that we can do, that's the fourth root of 81 cubed. And I'm only going to do it one way now. So the fourth root of 81 is 3, and we're going to cube that, so that's 27. Oh, and then pull your calculator out and check that, okay? I want you to pause at the end of this and do all of those with your calculator. Make sure you are getting these answers with your calculator, or come see me and figure out how to do it. Okay, this one we should try it as 0.75 to the 6 over 5. But that doesn't actually help us because 75 doesn't show up on our chart anywhere as being a perfect square, perfect to the 5, or perfect to the 6. It's, we know it's not because the 2 to the 4, 2 to the 5 is 32, 2 to the 6 is 64. So this is not going to be something to the 2. Well, plus it's an odd number. And 3 is, 3 to the 4 is 81, so we're past that. So there's nothing that's a perfect square. So we need to use a calculator for this one. So we get 0.7080 something something. So this is a use calculator question. Okay. If you're asked for an exact value for that, this is the exact value. This is an approximation. Okay? All right, pause the video and do the next 4 questions, please. Okay, I'm just going to put the answers down first. So if you got them right, you can skip ahead in the video. It's 0.000. Oops, that's too many zeros, sorry. Chocolate. But I get it this time because I found it. So this equals 81. This is 4. And this is 2.27709. You need to use a calculator for that one. Okay, if you got those, you can skip ahead a bit, and if you didn't, I will show you how to get them. So this top one is the square root of 0.04, and then cube that. So the square root of 0.04 is 0.2, and if we cube that, that comes up to 0.008. This one is the cube root of 27, cube root of 27 to the power of 4. So that's 3 to the 4, which is 81. This one, we need to change the decimal into a fraction. So this is negative 32 in brackets to the 4 over 10, which we then reduce to negative 32 in brackets to the 2 over 5. Ooh, that's 5 and 32. We know that, right? Okay, so this is the 5th root of 32 squared. And the 5th root of 32 we should know is 2, or negative 2. Ooh, I lost the negative. Negative. So it's negative 2 squared, which is positive 4. Right? Last page. Applying the formulas. Oh, this is easy if you've actually stopped and used your calculator every time I've told you to. This is easy. Biologists use the formula B equals 0.01 times m to the 2 over 3 to estimate brain mass B kilograms of a mammal with body mass m kilograms. Estimate the brain mass of each animal. So we are asked to find B because it says brain mass, and this tells us that brain mass is B and it's measured in kilograms. So B equals 0.01 times m, which is body mass, 512 to the 2 over 3. You plug that into your calculator and you get 0.64 kilograms. Okay? Key for this is seeing that it tells you what the letters are. It tells you that body mass is the M and brain mass is the B. It tells you it's in kilograms. This one is pretty straightforward. For this one, same equation, 0.01. We're just going to put the cat's mass in here instead of the moose to the 2 over 3. And that equals 0.029 kilograms. Okay? And pause. pause the video, try the last two questions. I'm going to show you the answers for these ones. I'm not going to bother just writing the answer out because it doesn't take any longer to write the actual equation to 2 over 3, and that equals 0.09 kilograms. And for polar bear, B equals 0.01 times 200 to the 2 over 3, and that's 0.34 kilograms. Okay, that is it. See you in class. Bye.